Hello everyone. Welcome all of you to AIK Pathsala, and I am your instructor Anup. And this is the second session of machine learning. We are actually studying dimensionality reduction technique. During the last session, what we have studied, let me just give you a brief summary of the last session. Then thereafter we will start. So we have covered what is dimensionality reduction technique, and this comes under the ML. And usually people study this technique after studying the ML algorithm, but I am covering it first. Thereafter, I will be covering other things. So thereafter, I have told you that what is dimensionality reduction technique and why should we learn it. With the help of this table, I have explained you the rows and column concepts, and I've given you the example of the students, and these are the features of the students in each of the columns. Finally, we have thereafter we have studied in the EDA to deal with lower dimensional data like 2D data and 3D data, and to visualize that data, we have a scatter plot. And for the higher dimensional data, like 4-dimensional, 5-dimensional, till 6-dimensional, we used to do with the pair plot. And this is the formula for calculating the number of pair plots. With the help of this NC2, you can calculate how many. And this is a 2-dimensional visualization of data, and this is a 3-dimensional visualization of data. And one thing is that human eyes are equipped to visualize only till 3-dimensional data. But what if we have a higher dimensional data, like let's say 10-dimensional data, or 1000-dimensional data, or 100-dimensional data? So in that scenario, we are not able to visualize the relationship between different features inside this data. So for that, we need to reduce the dimension of the data from n-dimensional to, let's say, 2-dimensional or 3-dimensional, so that we are able to visualize it with our eyes. So this is the reason why we are studying the DRT, or dimensionality reduction technique. Inside that technique, I have told you that there are basically two types of technique. One is called principal component analysis, whose short form is PCA, and other is redistributed stochastic neighborhoods embeddings, which is called TSNE. And this is a old technique. PCA, I have told you, this is an old technique, and this is a state of the art in visualizing high dimensional data that I have told. Thereafter, I have what I have discussed, that in this after few sessions, I will be taking 1784 dimensional data, and we are applying this dimensionality. First, we will be learning the dimensionality reduction technique, that is PCA and TSNE, and then we will be applying that technique on the 784 dimensional data, which is my MNIST dataset. MNIST dataset. I will be discussing this MNIST dataset thereon. Finally, we have studied about the row vector and the column vector, and I have explained you with the help with reference to the iris flower dataset. So for any given flower, we have 4 features: sepal length, sepal width, petal length, and petal width. And we have we have 4 features, and we have 3 levels, that is setosa, versicolor, and virginica. That is yi. Fine. And this is my xi, and this is my yi, which is having either it can be setosa, versicolor, or virginica. So any kind of flower can be classified into one of the 3 categories that we have studied. Finally, we have stated you this is a column vector. And by default, the vector representation is a column vector. Why it is a column vector? Because it has only one column and a many number of rows. Here xi belongs to RD. This is a d-dimensional column vector. Here d means d-dimensional column vector. And here this R means real values or real space. Fine. And this is a D cross I. This is a matrix representation. This is D crosses because it has a D number of rows and only one columns. That's why it is D cross 1. And I have told you that default vector notation is a column vector. That means if I have this features like this, and this is a row vector, that means xi is this thing. If I represent xi is this is just a opposite of the column vector. Why this is opposite? In the row vector, we have only one row and many number of columns. Here we have a single row and multiple columns. So you can see we have one row here and 4 columns. This is also xi belongs to RD. Here D is the features or dimensions, you can say. Thereafter, finally, we have studied the data set can be represented, representation of a data set. So this any data set can be represented at xi, yi, where I belongs to 1, 2, and this is the number of data points. This is xi is basically the data points and yi is my class levels. In the context of the IDs flavor, we have the class level as Setosa, Virginica, and Versicolor. So for every xi, we have some xa, we have some ya, and here xi belongs to RD, that means xi belongs to R. Here 4 means we have 4-dimensional data. The value of D is 4 means we have a 4-dimensional data. Why 4-dimensional? Because there are 4 features of iris flowers. What are the 4 features? 1, 2, 3, 4. And this is my class level, Setosa, Versicolor, and Virgin. So this is all we have studied in the last session. Now, in this session, are we fine till here? May I get a quick yes or no? Then I shall move ahead. Shall I move ahead?
Yes.
Fine. So today what I am going to study. So today the data set as a, I am going to study data set as a data matrix. How to represent a data set as a data matrix. So let me write it. How to represent data set as a data matrix, or you can say as a matrix, Fine. So let's try to understand this thing, what I have written. So first of all, so what is this? So see, one of the very common way of representing a data set is using a matrix. So matrix is one of the very common way of representing a data set. So first of all, what I will do, let me first create a data matrix. Thereafter, I will explain you. So let's see how to represent it. So before doing that, let me first create a data matrix for you here. So just try to understand what I'm going to create, and then we will understand it in bits and pieces. So this is, let's say, if this is my one thing, and if this is, let's say, so, and fine. Let me take some other color. Let's say we take this color. This is F1, this is F2, this is F3, so on so forth. This is, let's say, Fj, and this is, let's say, Fd. Fine. And this is, let's say, 1. This is my column, sorry, row 1, 2, 3, till, let's say, this is somewhere ith column, row, and this is, let's say, n number of rows and d number of columns. So, and this is, let's say, some, here I am representing this matrix as x. So the value of x is this. Now let's try to understand this first. And let me also represent this thing. So it will be a great idea if I will. So this is my, let's say, if this is this, and if this is my xi, so I can write it as xi transpose. Fine. Let's understand what I have created. So basically, a data matrix, what I have written, how to represent a data set as a matrix. So basically, a matrix is basically like a table. So if you will look at this, this is basically, it looks like a table. Suppose if my data set D is a, let me write it here. Suppose if my data set D is a collection of xi and yi. So this is my, let's say, xi, and this is my, let's say, yi. This is a collection of xi and yi, where I is going from 1 to n. Fine. This is my data set. Now, if this is a data set, that means we have studied xi belongs to Rd. This Rd. What is this? xi is a d-dimensional, where xi is a d-dimensional vector. What is this? This is my d-dimensional vector. Correct. And this xi has, and this xi has d features. D features. Because it has d. And this is a, so this means xi is a d-dimensional vector, as you have, as I have written, and which means d-dimensional vector means I have d features. Yes. So I can write my features as column of my matrix. So when I say as a column of my matrix, this F1, F2, F3, Fj till Fd, right? So, and here I have 1, 2, 3 till n. So I have n data points. This is my data points. So I have n number of data points. If you look at this matrix, I have an n number of data points and I have d number of features. Features means column. So I have this column, this column, this column, this column till this column. And I have this data point till n data points. Fine. So I have first data point. This is my first data point. This is my second data point. This is my third data point till nth data point. Similarly, if I talk about the features, this is my first feature. This is my second feature. This is my third feature till dth features. Is it okay? Now, shall I write it as, here, if matrix representation, I can write it as n cross d. Why? Because this is row, this is basically my row, and this is basically my column. That means in this matrix I have n rows and d columns. Fine. That's why I have written n cross d. Now one very important thing that I would like to address you here. If, let's say, if I take this data, ith data. So ith data is having this number of features, F1, F2, F3. So ith row is, what is the ith row of data? Ith row of data is nothing but your xi transpose. So I am representing each data point.
Sir, can you please repeat this one that before the ith point and xi transpose?
I'm coming to that point. I understood why there is a confusion. See, what I have told you in the last session, by default, any vector is a column vector. Until unless there is a specifically given any vector, the default vector is a column vector. Fine. So if I take this row vector, this is a xi. But by default, this is a xi is a column vector. So what I did is I write a transpose here. Transpose means I'm converting this.
That is the opposite, like it is a column vector, then it
Right.
is SI
By
transpose, it will
default, it
convert it
is a
into the
column.
row vector.
Correct. By default, it is a row vector. That's why when I am writing it as X transpose, so it is getting converted into the row vector. Because by default, any vector is a column vector. That's why I am writing it at X transpose. Fine. So X, when I have written it as a Xi transpose, then that it becomes a row vector. So if Xi is a column vector, Xi transpose means let me write it here for your understanding. So if xi is a column vector, that means xi transpose is my row vector. Basically, what I'm doing, transpose means swapping. Basically, I'm swapping here. I'm doing the swapping. Transpose and swapping. I'm doing transpose and swapping. Correct? And let me write something else also. Let's say each row is my each data point. Is it fine? And each column is my feature. FEATU. And let's say each column corresponds to xi means I have already written xi means column vector. Fine. So xi transpose means transpose of x. Let me write it here. xi transpose means transpose of x. Fine. Now, similarly, so if you look at the column, here also, this is F1, this is F2, this is F3, and this is Fj. So Fj here means jth features. This is my jth feature. And here each column represents a feature, or you can say variable. Fine. So in case of, okay, we will come to this. So there is also exactly another similar way of representing where x could be represented as, let's say, let me do one thing. I am taking this entire thing on a different, I'm just copying here. Let me copy it, and I'm going to the new page and just pasting it here. Paste and paste. Why the pasting is not working? Okay, let me do it again. So if I take this thing, let's take this thing. Let's copy and then let's paste it. Why this paste is not working? I don't know. Let me try it once again. Should be working, because I don't want to do the same work again. What I have done it here. Is this copy? Copy. Fine. Now it has plot. So, are you able to see this? Let me take it here. Fine. Just I am erasing these features. Fine. And I am erasing this thing. Rest everything will. And let's also erase this. Now, what I want to say you, we have understood this thing, a one way of representing a data set as a matrix. There is also exactly another similar way of representing where X could be represented as this. So here what I have taken, here features are in the column and data points are in the rows. But here what let's write here. Here I am writing my features as my in the row F1, F2, F3 till let's say Fj until Fd. And I am writing this as in the column data points 1, 2, 3, 4. Let's say this is my ith data point, and then this is my, let's say, n. Fine. So what is the difference between these two? Simply here, whatever I have written in the column, I have swiped the column from the row. So in this way also we can represent my data. So here each column represents a feature. If you look, sorry, each row represents my features. This is F1, F2, F3, Fj, so and so forth till Fd. Okay. And each of my data points could be represented as column vectors. So column is my, here, column is my column, column is my data points. Fine. And row is my features, variables. So if I look, this was my n cross d matrix, and this is my d cross n matrix, because there are d number of rows and n number of columns. Now, let's say my ith point here is xi. This is my ith point. So this, my xi could be here. My xi could be, this could be my xi. This is my xi, ith data point. So this can be my xi. Fine. Now, this is, means in this case, each column represents my data points and each row represents a feature or variable. So let's say if I take the case of iris flower, let's take the case, sorry. Stop save. Let's take the case of iris flower. So I'm taking the case of iris flower. And we know iris flower has 4 features. So let's say it has 4 features, that is F1 is equal to petal length, F2 is equal to, let's say, petal width, F3 is equal to, let's say, sepal length, and F4 is equal to, let's say, sepal width. So these are the 4 features of my iris flower data set. And this is my X. So if I take the iris flower data set, so your F1, this F1 could be my petal length, F2 could be, sorry, not this. This F1 could be my petal length, this F2 could be my petal width. This F3 could be my sepal length and F4 could be my sepal width. So these are the two representations. You got your point? So this is a one representation, one way of representing a data. This is a one way of representing a data, and this is a another way of representing a data. And this x that I have here is basically, this new x that I have here is basically transpose of the x. So if I just swap rows with columns, if you just swap rows with columns, what you will get? You will get this matrix. If in this matrix, if you swap this column with this row, then you will get this matrix, or vice versa, you can say. Fine. But so both of the representations that we have looked at right now are, both of them are valid. In lot of research papers, you typically find this type of representation. That's why I have discussed this type of representation. You will find in a lot of research paper. Fine. And so what they have done? Basically, xi is a column vector by default, we have understood. So they just stack up all the column vectors. Can you see? This is one column vector, this is one column vector, this is one. So they have stacked up all the column vectors like this. Fine. So to make this whole matrix look like this. Fine. So, but what I studied, and according to my experience, what I have seen, I have used this format more. You will see more commonly this format, you will see everywhere. So only important thing here is that as long as somebody tells you what each column and what each row is, it's fine. I will stick to this representation, where each row is my data points and each column is my features. Correct? I prefer this because it looks more like a table, and there is no right or wrong approach. As long as you specify what you are doing, it's fine. Fine. So this is one thing. Now let me take you to the next thing. Let's understand something more here. So let me first, before going ahead, let me first draw one. So let me first draw one table here. So let's take this table. I'm taking this table. Let me draw this table here. So let's draw the table. Fine. And let's draw this thing. I'm drawing a table. Drawing a table. Fine. And this is, let's say, 2, 3, 4. Fine. So this is a table. Now I want to discuss this table in context of iris flower. Iris flower dataset. So let's say I have, this is my x1, this is my x2, so and so forth. Let's say somewhere here, this is my xi, and this is my, let's say, x. Fine. And this is, let's say, f1, this is my f2, this is my f3, and this is my f4. So can you guys tell me what are the 4 features of the iris flower dataset?
Sepal length, sepal width,
Sepal width,
petal length, petal width,
petal length.
petal width.
Okay. Let me petal length, and petal
width.
Fine. So these are the 4 features of my iris flower data set. So if you will look at this, table, so I can think of my data as a table. Oh. So if you will look at this table, I can think of my data.
Okay, screen is not visible, sir.
Is it so?
Yeah.
So my screen is not visible. Okay. Is it visible now?
Now it's visible.
Okay, thank you, sir. So I can think of my data set as a table where each row could be my sepal length, not each row, each column. Each column could be my sepal length. Sorry, each row. I can think of my data as a table where each row, let's say, take this row. So this row is having one data point, and that data point has 4 things: sepal length, sepal width, petal length, and petal width. So I can think of my data as a table where each row could be my sepal length, sepal width, petal length, and petal width. Fine. So my 4 features F1, F2, F3, F1, F2, F3, and F4, and each of these could be my flowers. So my first flower, what is its sepal length, sepal width, petal length, and this is my first flower. So in the first flower, what could be my sepal length, sepal width, petal length, and petal width? My second flower, this is my second flower. This is my third flower, so on, so forth. First, so looks, this looks very similar to typical tabular representation of data. This is how you tabulate your data. Each row is typically a flower. Each row is typically a flower, or you can say a data point. And each column is basically my features. But a lot of research papers prefer to use opposite of this. It's perfectly okay to use any one of it, but we will stick to this because what I'm just more used to it, you can say, and it feels more natural to it, especially when we are tabulating the data. So there is one more question you may ask. It might have occurred in your mind. You explained how to represent X. Fine. So you explained. Let me take you to the first sheet of today. This sheet. So you can ask me. So you have explained about the X, how to represent X. But what about Y? What about Y? So let me tell you this thing. Of course, I can represent Y as a column vector here.
तो उसका तो हम सेम ही रख सकते हैं ना. It's just like we are just writing xi, xj. We'll just replace it with the yi and yj.
Let me explain you first, then you can ask your question. Sorry. If let's say this is my, if I represent my Y as this, if this is my X, this can be my Y. So here I have not previously added my Y. Now I have added Y. I will give you, Y is also called label, as I have also told you before. And let's say this is the value of Y. This is my 1, 2, 3, whatever. Let's say this is my I, and likewise till N. And what is its representation? This is n cross 1. Fine. Here, this is my row vector. Fine. So, I can represent y as a column vector here. So, this is a column vector. If you will see, this is my column vector. So, I can represent my y as a column vector. Y is my level. Why I am telling it as a level, I will explain you that in some time. I have already explained you this thing, but I will again explain you. So, what about y? What is the length of y? So, since this is a column vector, so you can see the length of y is same as the length of this x. So, n is the length of x. So, n is the length of y. Fine. But y has only one column. That's why this is n cross 1. Which means I have n rows and one column. And this is my ith row. So, this is the first row, this is second row, this is third row till this is ith row, and this is my nth row. Fine. So, for each data point x, what it means to why I am representing y as like this. See, if you take the case of, let me explain it here. Let's take flower. I have some features: sepal length, sepal width, petal length, and petal width. These are the 4 features. If I write some values here, for each of these values, I have certain level. That is, either it can be setosa, versicolor, or virginica. So this is a level, or you can say y. So for each of the features, if I have xi, x1, this is my x1. So x1 has certain values of these 4 values. Depending upon these 4 values, I have my y level as one of the 3. Either it can be setosa, versicolor, or virginica. In the same way, what I am telling you here, this is a general thing. For any values of x, I have these number of, for any value of, let's say, data point x, this is x1, let's say, I have these features. If I put the values of these feature, I should get some values of y, which is this. Similarly, for this data point, for the values of these features of these data points, I have certain value of y. What I mean to say here, for every value of, let's say, xi, I have certain y. So this xi, so this xi here I am representing, sorry. So this xi here I am representing as this, and this yi I am representing like this. I suppose this is clear.
Yes, sir.
So see, y could be just one column of data. Yi, as I have represented you, explained you, for every value of xi, I have certain values of yi. I have some values of, for every value of.
I think based on the data point and feature of a row, y is the outcome of that particular row, that particular x. Correct?
Based on the features of a data point, I have certain outcome.
Certain outcome. So y is the certain outcome of this x and y. Oh, x and f.
For the value, you can simply say for x, For
For
the value
X,
of X, have
there are
certain value of Y.
certain features. For that features, we are getting a certain outcome, that is Y.
Yes. You can also understand if you find it difficult, because these are the part of the actual machine learning thing, and we will be learning these things in very details in regression and classification and all those things. Just to give you an overview, let's say, just to give you a just an overview, I'm telling you. 2 days before, I have a blood test. Fine.
Okay.
So there are lot of parameters. So lot of parameters. Let's say, what is the value of my Na, Mg? Let's say I'm just taking some. What is RBC? My RBC count. What is my
CBC, and
TBC?
platelets.
Whatever. XYZ. There are. Let's
These
say
are the features.
these are the features. Now, based on these features, and these are the sample. Let's say this is my sample.
Sample 1, sample 2, sample 3.
There is certain prediction.
Correct.
See, you have this kind of problem. Or
Right.
based on this, there is a prediction. If these values lies between this interval, you are prone to diabetes. If this value fall in this interval, you are prone to this disease or that disease or this thing. So this is just a simple explanation.
Understood.
We will understand these things in more details in the coming sessions.
इसको मतलब कि alternate day पर whether we are taking 2 classes, अगर alternate day पे रखें, because long gap आ जाता है ना 3-4 दिन का, तो थोड़ा सा वो continuity में दिक्कत होती है.